am muted, yes. Good morning, ladies and gentlemen. I hope you can hear me loud and clear. Hope so. So I'm very pleased to be here today, but virtually, unfortunately, and I was making myself a real pleasure to go to Slovenia, as it would have been my first visit, but I don't give up. And as soon as we could, I'm surely will try to visit your nice country. We are here on the showcase. So it means that we will not speak a lot, but we will show you some results, because the aim of research and innovation is to develop tools, to develop technologies, and to be practical, to help people in their daily life. So just a few words to give the frame. We are in a transition towards clean energy, and clean energy implies to base our energy system on renewables. And we know that renewable sources of energy need some, let's say, adjustment to be stable along the time and to be sufficient. But we are also in a transition, which means a lot of impact on the various sectors of the industry. So the stability and the efficiency of the grid is a core issue for supporting the clean energy transition. Moreover, I'm happy to be discussing about that with the Slovenian presidency, because one of the great ideas of the EU is indeed to have cohesion and to serve the whole of the EU. And it is very important that the grid is harmonized. Paula Pino explained the critical role of digitalization for that. Here we will see some examples of what could be a good experience, good research innovation projects having an impact on the life of citizens and developing efficiency of the technologies and efficiency of the implementation, while, and this is an important condition, respecting the principles of sustainability, because everything you do with new technology implies using planet resource, and also respecting the needs of the citizen. I will not be longer, because the people to show up are the people present on stage and what they will present to you, which are very important things. A last word to say that research and innovation is critical for this transition. Research and innovation is critical for developing technologies, but also for helping with evidence-based and research to develop the frame. And last, for developing, as our Director General, Mr. Paquet, said at the beginning, for developing the link to favor living investment for implementing the results of research. So I would like now, I hope I am still on the time, and I will be terrible for respecting the timing. My colleagues will ensure that. So I will now give the floor, as I have two very good speakers who have already been introduced. I would like to give the floor for the presentation of the project on FutureFlow. Please, the floor is yours.
Hello. My time is very limited, so I simply skipped several slides. Sorry. What you see here on the screen is something's not working well. What you see here on the screen is the smoke from our largest thermal power plant in Slovenia. This photo was created a few years ago by my colleague, and some of you might have already seen it. Obviously, the slides don't work, but if the technicians can help me, please put on the previous slide. Okay. From the perspective of the FutureFlow, the big smoke represents all the thermal power plants that were and still produce electricity, not only for our everyday needs, but that also provide flexibility that is needed in the power systems. While behind the small smoke, there will definitely not be enough thermal power plants, and the flexibility coming only from those, plus other conventional power plants, will not be sufficient without new sources, which are in the power system desperately needed. As I said, my time on the stage is very, very limited, so the best way to show you what and why we did in the project is to show you our video. So please take a look at it, enjoy, and later on I come up with some findings. Now you can play the video, please.
There are many changes going on in the energy sector. We're producing more and more electrical energy from renewable sources. However, by closing fossil conventional power plants, we will lack flexibility services for regulating the balance on the network. Yesterday and today, such services were primarily provided by classic power plants, whereas consumers, prosumers, will largely have to fill in their role in the future. It is their potential to become the guardians of the power system. Consumers are the heart of the project. They are able, in a very short time, to increase or decrease their load and can become a new, environmentally friendly source of flexibility. By developing adequate business models, prosumers will get an opportunity to sell their flexibility to the most valuable market, reducing their electricity bills. If one of the national electricity systems gets into an imbalanced situation or line overloading, information is automatically passed to the consumers and renewable energy sources in its and other systems. They respond to this request by switching their electrical devices on or off. The FutureFlow project has developed a fully automated service that is able to continuously drive consumers and renewables up and down based on the needs of the power system. Real prosumers from Austria, Hungary, Romania, and Slovenia took part in our cross-border pilot. With their 48 megawatts of flexible power, they demonstrated that prosumers can deliver high-quality and flexibility services to the TSOs. FutureFlow simulations show the potential to save 23% of regulating energy by the integration of flexibility markets in these 4 countries. A further shift of the fossil fuel technology to DR and DG represents a significant step towards our independence from fossil fuels and the achievement of challenging CO2 goals.
I hope you enjoyed the video. As you saw, FutureFlow did not stay on the level of scientific papers, and we are really proud of that. We are also very satisfied with the project results. Not because of the reward we received, but because of what we did in the field. In the previous session, we heard what we need, and we did it exactly. We brought so many prosumers to the project, so many megawatts, and we kept them motivated in the pilot tests for 1 whole year. I think this is really a huge success also compared to other projects. But when, after 2 years after the end of the project, I take a look at the reality, I get worried. Worried why? We know that we have proven the technology itself is not a threat, since even the passive traditional elements, if they are properly aggregated, they can change their behavior and operate in the most challenging system services. The real threat is the motivation on the side of demand response and the spur generation. Last year, for example, when the prices dropped to COVID to the bottom, logically we did not expect any new entrants. But this year the prices are sky high, but there is still no motivation on the side of DSM. Maybe I'm not patient enough, but our time, as we heard, is not unlimited. If we don't attract sufficient alternative flexibility sources and the thermal phase out come first, then this green transition will not be as pleasant and as cheap as we wish. So just last sentence from my part. At the end of the project, we heard prosumers saying, "We are ready." I know that prosumers technically are ready. We have proven this in the project. But are they motivated enough to start playing not the demo, but the real game? Thank you.
Thank you very much. I also applause. So I let now the floor to our second intervention, which is, I would like first to thank Mr. Kamar, that was extremely interesting. And now let the floor to Mr. Todt, who will present another type of approach, which is mainly on the side of investment, and then something different for efficiency. So Mr. Todt, the floor is yours.
Thank you very much. So my name is Simon Todt and I'm coming from ELES, Transmission System Operator of Slovenia. And I would like to present you our experiences in how to innovatively design and implement international smart grid like PCI project SINCRO.GRID and international project NEDO. So, supporting the renewable energy sources integrations is a very important process during the transformation from the centralized to the decentralized of the system. Of course, we have a few possibilities how to achieve these goals, and market integration is one of them, and the second one is strengthening of the corridors. Unfortunately, we have some obstacle in this way because we have to aware very time-consuming process to get the permission to build, to construct the new power lines and put it into the place. So the next thing is relatively high cost of new infrastructure. But we can get to some obstacle also because during the transmission of the electric energy from between the 2 points, we have to aware that the commercial flows and physical flows is not the same. Unfortunately, this acquires some measure like dispatching, the redispatching, and to find solution for bottlenecks, congestion, and so on. And according to the available data, information, the cost of this measure exceeds €1 billion per year for all Europe. So, what can we do about this? I think there is a third solution, so-called grid controllability. What means grid controllability? This is simple to increase the flexibility of active power, increase the flexibility of reactive power, voltage control, power flow control, but we have to everything upgraded with the new organization, new tools, new algorithms, and new organization. We can, because I already mentioned the obstacle to implement new types of power lines, new corridors, we have the possibility to postpone some of this investment by implementing the dynamical thermal rating system, and this kind of system allow us to increase the transmission capacity on the existing power lines. This could help us during the process of the transformation and, of course, save some money. And all what I mentioned concerning grid controllability, we are taking into account in our project, and now I just want to put the video where it is more deeply present.
The Slovenian and Croatian electricity transmission system operators, ELES and HOPS, have faced the challenge of overvoltage in some parts of the network. In addition, they perceived new challenges due to the growing share of energy produced from dispersed renewables and the increasing need for flexibility. Therefore, they decided to find solutions together. They teamed up with the Slovenian and Croatian electricity distribution system operators, SODO and HEP ODS, and initiated the first European project to introduce digitalization into the energy infrastructure, SINCRO.GRID. The partners integrated already established technologies into the Slovenian and Croatian electricity network in an innovative way. They installed 6 compensation devices, 3 variable shunt reactors, 2 static VAR compensators, and a mechanically switched capacitor with damping network. With those devices, they achieved the voltage profile control and the possibility of voltage regulation in the electricity systems of both Slovenia and Croatia. To increase the flexibility of active power and thus the reliability of the system operation, 2 battery energy storage systems were installed. The dynamic line rating system calculates the dynamic thermal limits of transmission lines for operation in real time and short-term forecast based on improved DLR algorithms and models. ELES and HOPS utilize results to improve the safety of operation and the transmission capacity of the network. This way, the existing infrastructure is utilized in the most efficient way. In both national control centers, a joint application was installed, forming a unique cross-border virtual control center. This is the first case in Europe where neighboring transmission system operators have joined forces in regulating and optimizing the voltage in their networks. Joint integration of devices has increased the economic efficiency of the investment and has also had a positive impact on the networks of neighboring countries.
So, why we think that SINCRO.GRID is very important? Firstly, because it is introducing innovation of the power grids, but with the possibility to the replication all over the Europe. Second one, the project is very cost effective because we save at least one compensation device in each TCO because for the gather designing and collaboration between 2 TCOs. And the third one, we manage, in this case, we managed to upgrade the commercial system, commercial devices with the smart grid devices. And for the conclusion, I just want to point out three messages. So, grid controllability is one of the 3 key elements supporting the renewable energy sources integration. The second one, you should look for more grid controllability in all Europe system. And the last, but very important, we have to switch from the national to the international planning, designing of the project, and of course the implementation such of the project. So with this, I just want to close with the presentation of the first project, and I would like to start with the new one. Okay. Shall I go?
We should accelerate maybe a little bit. I'm sorry, we have another session coming now.
Yes, I just want to put some information according the second project. This is NEDO project. NEDO project is the same project like SINCRO.GRID, but on the level of distribution level. So we are talking about the grid controllability on the distribution level. We are dealing with the consumers, with the cities, municipalities, and so on. But if everything is summarized, the project is the grid controllability on the distribution level. So I just want to put a short...
Project NEDO is a smart grids and smart communities international project in Slovenia, cooperatively executed by the Slovenian transmission system operator ELES, Japanese agency NEDO, and its entrusted party Hitachi. The electric power system is facing considerable changes due to the liberalization of the sector. Climate change is causing extreme weather events more and more often. The need for a greener future involving the transition from fossil fuel power generation to renewable ones demands a vast change in concepts of operating and planning for the electric power system, and grid in particular. The brain center of the project is in Kleče, where advanced distribution management and area energy management systems are installed to run advanced functionalities across all filed locations, optimizing energy transfer and consumption. At different locations across the country, the existing infrastructure was upgraded with advanced equipment such as network control devices, sensory equipment, local voltage controllers, on-load tap changing transformers, protection relays, home energy management systems, and battery storage. We developed advanced functionalities that enable coordinated voltage control, fault location, isolation and system restoration, closed-loop operation. Even the smallest consumers were included in the energy markets, participating by changing their demand based on signals from distribution operators. Demand was even reduced by 30% at selected hours. The project will provide invaluable lessons learned to enable the transition of a power system that will be resilient, able to include new generation and loads, and cost-effective.
So, because my time is up, I just want to conclude and give you information. The project NEDO with Slovenian and Japanese colleagues received the excellent award of excellency from the International Smart Grid Action Network, and we are, and our colleagues from Japan are very proud of this achievement, and I think this is a quite nice presentative what shall we do during the transformation of the system. Thank you very much.
Thank you very much, and I'm really sorry for all the timing requirements. I would like to finish with two very short questions to the two panelists. First, to mention that the FutureFlow, the first one, we had the video, has been funded or is funded by the Research and Innovation Program Horizon 2020. And second, that indeed, the second project is getting or got an award from the International Energy Agency. So we had one project purely from research, another one with investment, and a third one with an international dimension. We are in the set plan conference. So my question will be straightforward to the two panelists. What would you like to ask to the set plan, and especially to the EU research and innovation policy, to do in coordination with member states for further developing the approach you have already set up with this project? What would you ask us, the EU, and our colleagues from the presidency and all the member states to do within the set plan? Mr. Kama, please.
Yeah. My question would be, today we already spoke and it was mentioned the people's awareness and our duty towards, let's say, energy transition. How can we increase the awareness of the citizens? Because we know we have citizens who simply sit in their living rooms, watch TV, and they expect reliable energy supply. Then we have other people who install solar panels on the roofs and think this is what I have to do and that's it. They, at the same time, they use electricity for heating, they don't care about efficient use, they drive diesel cars, etc. And then we have, let's say, the third group of people, and that's us. Us who are aware of energy efficiency, who install our solar panels, who are aware of our responsibility and our duties, and are also willing to, let's say, accept lower level of reliable electricity supply and even to pay higher price. I don't know for how many years, but with the final goal that our kids will live the green life. So my question is, I think, targeted towards citizens, how to increase the awareness of the energy transition and that we will all understand the concept of the Green Deal.
Thank you. And Mr. Todt, very quickly. Mr. Todt, very quickly.
Yes, I hear you.
So what could you ask us, EU, and also research, and also ask us a set plan in coordination with member states?
So I think the question, or more or less, is the proposal is that we have to find, because we already know how much cost we have during the redispatching, cross-bordering processes and so on, and we have to find the solution and to invest more money to the projects which are increasing the grid controllability, because I think if we would like to move to transform the energy from the north to the south or west to the east, we have to be prepared, and we have to know how to deal with it and how to control and make the system as safely as is today. Because if we don't do nothing about this situation, we can have the problem with the lack of the energy in one side and the too many energy in the another side. So I think this is the first question or proposal, and the second is how and to manage to gather all TCOs that they implement more and more projects together with the common optimization to look to the wider losses optimization and so on.
Thank you. Thank you very much. And with that words, I would like to thank the two speakers, Mr. Kramer and Mr. Todt, and thank the organizer and give back the floor. Thank you very much for the attention.